Hey class, welcome back for week 2's lecture content. Now, if I jump over here to the slides once again, as we see here on the slides this week, we're going to be looking at activities, activity life cycles, interactive UI, and really some more, diving deeper into what actually makes an Android app tick. So if we kind of look at our outline here for this week's content, we have kind of our first section here is going to be talking about the Android framework components. What are the building blocks of an Android app? The next section is going to be a review of the project we created last week. We'll be diving deeper into that project and looking more closely at what exactly is created when you create a new Android project and how those pieces work together and kind of what their purpose is. The next section will be diving deeper into working specifically with activities. How does an activity control what is on our screen? That's kind of the question we're going to be asking there. Then we're going to jump into creating interactive user interfaces. We're going to start actually putting different UI elements together and receiving input from those elements. So specifically, we'll look at how to define and interact UI elements. And then just at the end, we're going to do a little bit of an overview on just how to start testing on a real Android device. So this will be useful maybe if you want to actually show an app off to friends and family, if you want to just see what it's actually like to interact with the app you're building, or maybe you just want to try and see if a real device is faster for testing than an emulator is. All of those are great use cases, and we'll get in specifically on how to start doing that. So as we start off here, we want to frame this question of kind of what goes into an Android app. And a great place to start for this is to start with the Android framework components. And the question to keep in mind for this is, what are the building blocks of an Android app? So before we even get that far, maybe take a step back. Let's think about what is Android. Well, Android is a multi-user Linux-based operating system for mobile devices. These include phones, tablets, Chromebooks, watches, TVs, IoT devices, cars. The Android runs in a huge variety of different types of devices. Now, Android apps all run in their own Linux process, and each process has a unique virtual machine to keep it isolated from other apps. So this is one way in which Android apps really try and secure themselves. They run in their own virtual machine so that they're isolated from one another, and then there are very clearly defined boundaries and mechanisms for sharing information between apps. And now when we spin up a virtual machine, a process is created anytime an Android component needs to be run. So anytime an Android app is run, that process is going to be contained within a virtual machine, and that process will be created in response so that one of the Android app components can run. So what are the Android app components? Well, you can think of these as the core foundational building blocks of an Android app. These are the things that really can trigger your application to start running. So first off, we have an activity. Now, we saw an activity last week, although we didn't talk about it in too much depth. But an activity is a class that represents what is on the screen, and it is an entry point for user interaction. So an activity is really something that's on the screen that users can interact with. You can display information to users. It has that interactive and visual element to it. A service is the next Android app component. Now, a service does not include any type of user interface to it. And services are really there to enable us to do long-running tasks that need to run in the background. So a great example for this is downloading a movie, for example, or any other large file. Typically, we might kick off a download and then move on to some other app, or even just turn our phone screen off while we go about our business. In situations like that, We don't have any UI present anymore, but we want that download to continue running in the background. That's where a service comes in. The next Android app component is a broadcast receiver. Broadcast receivers enable sort of messaging across components and applications and the operating system. They enable the operating system to deliver those event messages and inform our applications that it's time to respond to certain events. So this could be a connectivity change event. Maybe the Wi-Fi comes back on. We can respond to that. This could be for an event like a new contact being added or something, or a new notification coming in, and we need to respond to that. There's lots of different types of messages that we can register for and then respond to using a broadcast receiver. And once again, I'll just call out, broadcast receiver doesn't include any type of user interface. If we needed to respond to some type of message with the user interface, it would likely go through a broadcast receiver, and the broadcast receiver would then tell us how to launch an activity, which would then contain some user interface. And now the last app component is a content provider. Now, a content provider is a class that manages app data shared with other apps. So again, this doesn't include any type of user interface, and it's really here to define clear boundaries for how data can be shared from one app to another. So now we've talked about how these components can work together and a little bit about their responsibilities. Now, these components can communicate with one another, and this communication generally happens using an intent. An intent enables communication between activities, services, and broadcast receivers. Intents can specify a specific component, such as a specific activity in your application. An intent can also specify a general action that it wants to take. You could create an intent, for example, to send an email, and the operating system will then choose from a variety of options, all of which can handle that email. That's why sometimes if you try to share a message, for example, or share a link, you might get a lot of different apps that you could share that through. That's because those all know how to handle the email intent, or maybe a link intent. You can also put sort of somewhat arbitrary data within an intent, and this is particularly useful for messaging between, let's say, an activity and another activity, or an activity and a service, because you might need to pass an identifier around or some type of result code. This type of communication specifically, we will get into in this course. Now, the next thing you want to take a look at here is the Android manifest. And if the Android manifest sounds familiar, that's because we have an Android manifest in the application we created last week. Now, what exactly does an Android manifest do for us? Well, an app's manifest is responsible for registering core components with the operating system. So any of those components we just talked about, content provider, broadcast receiver, activity, service, those all have to be registered in the manifest so that the operating system knows about them. If the operating system doesn't know about them, then it can't route messages to them. It can't instantiate them properly when it needs to. Essentially, your app will not run properly if those components are not registered. So the Android manifest is very, very important. The manifest also serves a couple other purposes. It allows us to identify what permissions our app is going to require. It allows us to declare certain specific types of hardware features that we might need for our app as well. We also can use the manifest to define certain deep links that our app is responsible for. And if you're not familiar with a deep link, think of it basically as a URL that you want your app to respond to. And so if you register that deep link, your app then knows which activity to run in response to that link being clicked, or what service or something to kick off. So the manifest does a lot of things for us, and we are going to explore exactly what is in the manifest of the project we created a little bit later in this week's lecture. Now, Just for a quick overview here too, here is an Android manifest example. So the manifest is defined using XML. That XML typically has a kind of a top level manifest tag followed by an application tag. Within the application tag, we'll see things like app icon or app title. We'll look at those later in our demo. But then you can see here an example of an activity being registered in the manifest. In this example, the activity is called example activity, and we can provide a label to it, which is the label that might get displayed in the task switcher or in the toolbar when you run your activity. Now, similarly, like I mentioned, you can define a service or a receiver or a content provider. And these are just small examples of what tags you would use to define all of those within the manifest. So, an Android app then could be defined as a combination of app components that receive events from the system, communicate with one another in a secure fashion, and include some type of interactive user elements. Those types of elements are essentially what we see and work with on a daily basis when we use any app. All of the other stuff, the communication, the messaging, all of that type of stuff is really happening in the background and is hopefully pretty transparent. We don't want our users typically to know how things are working in the background. So if we build our apps in the right way, all they have to care about is the nice user experience that we're hopefully providing to them. Now, so as we mentioned a little bit previously, in an Android app, the activities are responsible for what you see on the screen and what the user interacts with. We saw this last week in our example. We had a main activity, and that activity had a layout within it. And in that layout, we had a text element that said, hello 8340. That's generally how that process works for getting something from an activity onto the screen. Now, any activity must define a layout, and that layout can contain really any number of layout containers and views. Now, views could be things like buttons, text, a toggle, a progress bar, something custom that you build for your specific application. Anything that really can be drawn to the screen. Now, an app can also have any number of activities and can transition between those activities as needed. So we don't have to build our entire application within a single activity. And in fact, you generally want to think about how you can break things up. You might have very specific entry points into your application. Maybe you have a browse experience and an edit experience. You might want those to be in separate activities because you might be able to jump straight into editing if you click on a specific deep link, for example. So it's a good idea to think about conceptually, how could you break a task down or break some functionality down and group it into activities or other types of logical containers that we'll get into throughout the course of this course. Okay, so now we have a basic understanding of the core Android app components, how those are registered in the Android manifest, and a little bit of their responsibilities and how the Android operating system can route messages to those components, and then how ultimately we can use an activity to actually show something on the screen and interact with our users. So now that we have a little bit of this fundamental understanding, let's think about reviewing the project that we created last week. So specifically, what was generated in our new project? And how do those files and classes and resources all work together to basically build the application that you submitted in your homework assignment? So a few of the things that we're going to look at here, and hopefully some of these maybe jog your memory and seem a little familiar from what you were working with last week. So we're going to look at main activity and also activity_main.xml. We're then going to review the project structure a little bit and see a little bit more closely how we can view these files. We're going to review the Android manifest for our app. Then we're going to look at our strings XML file, colors, styles, And we'll also look at a build.gradle file. And these Gradle files are kind of the build configuration for our project and help the Android tooling compose everything together and spit out the APK file that you submitted as part of the homework assignment. So real quick, the main activity is what we're seeing on our screen. The activity _ main XML defines the layout. setContentView is a method on the activity that sets the layout into the activity, and the main activity is declared in the Android manifest. Now, if that all sounds a little abstract, that's okay, because we're going to jump over to Android Studio. There we go. So let's kind of run through that one more time, but this time we can look more specifically at the code. So like we said, we have our main activity, and this is the same main activity that we saw last week. So main activity here is a class, and it extends appcompat activity. So in this sense, we're thinking object-oriented programming here. Main activity inherits everything from appcompat activity, and then we can override certain methods to customize the functionality. So in main activity, we are overriding the onCreate method. Now, onCreate is an activity lifecycle method, and we're going to talk more specifically about the activity lifecycle in a little bit. But in this case, onCreate is the perfect place for us to define the layout XML of our app. So like I mentioned, we call setContentView, and you have to pass a layout file into setContentView. So in our case, our.layout.activityMain represents the layout that we want to use for this. Now let's talk quickly about the syntax here. R basically is a generated class. R stands for resources. Layout is meaning that this is a layout resource. And then this is the specific identifier. So if we click into activity main here, we'll see over here on the left hand side of the screen in my project window, I have this layout directory. And as I expand that, I see the activity _ main XML is within that layout directory. So that's why we end up with this very specific convention for referencing our layout resources, as well as any other types of resources. And again, we'll see examples of that down below. But so if we had a string, it would be r.string and then the name of the string resource. If we had a color, it's r.color and the name of the resource. So here we have activity main. And if I come over here to my XML version of this, we see just what we saw last week. We see a text view here, and back over in our blueprint view here, or the design view, we see that we have this single line of text outputted to our screen. And if we were to deploy this, as you all know from the homework assignment, we would see this text printed out to our screen. So now that's how we get the element defined by the activity. Now to actually get the activity onto the screen and registered by the operating system, we have to register it in the manifest like we talked about. So if we look at our app here again, under the source directory, we come down here into source main, and right here we see Android manifest.xml. This is the common convention. Within any type of app directory, you have the module. In this case, we have a single module called app, and it's always under source, main, and then Android manifest.xml. So if we open up our specific manifest from this homework assignment, we see our top level manifest property here. We then see the application tag. And like I mentioned, we can define a number of things here. We have an icon. This is the icon that you actually would see in your app launcher when you go to actually open up an app. We have the app label. This is the app name when you would see it in your apps launcher. We have some other properties here like round icon, supports RTL. This stands for supports right to left. And this is for locales that read from right to left. And then we have an app theme. We'll mention a little bit more of the app theme later, but if we quickly kind of open up the app theme, a theme is just another resource type here. See here, this theme is defined in the styles.xml file. And basically we define a new style called app theme. It inherits inherits, from this predefined app compat theme. This is a great starting point. We're not going to get too much into the theming this week, but app compat basically is a series of libraries, resources that help make sure your app looks great on all different versions of Android. The key thing I want to point out here, because it will be a part of the homework assignment this week, is that we have 3 different colors defined in here. These colors are color primary dark, and color accent. And as you tweak these, your app will begin to look different. So now we go back over to our Android manifest here, and we see that we have registered our activity using this activity element. We've provided the name, which in this case is just .mainActivity. We could fully qualify this by saying com.goobar.io and provide the full name here. However, that is not typically necessary if you're only really dealing with like one module or one grouping of files. So if you want to just leave it as .mainActivity, that should be perfectly fine. And now the last thing I want to point out here is this intent filter. Intent filters are a means of sort of signaling to the system that, hey, I handle certain types of actions. This is one of those things where if you're sending a message out that says, how do I handle sending a tweet? You might define an intent filter that helps you say to the operating system, hey, I know how to handle that. So in this case, we have a very special intent filter applied. We have an action of main and a category of launcher. These basically define the entry point into your app. So whatever activity has this specific intent filter will be the activity that the operating system starts when it launches your activity from the app launcher. And so just a little bit more on that. So like I mentioned, intent filter is included to indicate what activity to start on launch. Intent filters describe categories, actions, basically things that can be handled by the specific component that the intent filter is registered to. And then we saw that the title, icon, and theme are all defined in the manifest for the application. So now let's review the project structure a little bit. So we'll go back over to Android Studio. And the first thing I just want to call out is, again, the project window over here on the left-hand side. So you see right now I have this in this dropdown, I have this marked to project. And the way this is laid out right here, these files, the resource, everything, this is exactly how it looks on the file system. So if you open up a new file browser, you would see in your application directory, everything laid out exactly the same way. And so if I go into this again, like we saw before, within the app module here, or the app directory, I see this structure. I see a build, I see libs. Most importantly, I see source. And if I continue to scroll down in this, I see source, I see main, Java, and then eventually I see my class, my main activity in this case. I also see my resources in here. And you can see we have multiple sort of directories. So for example, we have mitmap HDPI, mitmap MDPI, mitmap XHDPI. These are basically specific resource directories for different resolutions of screen. And I point these out specifically because this is one of the key differences between this and the Android project view. So if I come back up here to the dropdown and I scroll to the bottom, I click Android. This is going to reorganize how all these files are presented. They're still organized the same way on the file system, but they're organized differently here on the left-hand side. So the first thing you might notice is we have this folder here specifically for manifests. So it shows us all the manifests present currently in this project. You also notice here we have res. So this is the resources. It pulls those resources up and makes them easier to find. And now notice here, instead of having 4 or 5 different mitmap folders, we have a single mitmap folder. And if you drop that down, we'll see that it kind of consolidates all of them. So instead of having IC launcher PNG defined in 5 different directories that we have to look through, it kind of includes them all into a single place here that we can view a little bit more easily. And we can see that they're all related to one another. Now, similarly, if we want to look for our source code, we can come to the Java directory, which I know is confusing since we're writing in Kotlin, but it's just sort of a historical convention that is still in place. So if we open up Java here, we'll see 3 kind of directories. We see this main one here. We see one called Android Test and one just called Test. So these are kind of by default the 3 source sets that are created. Now, what is a source set? Basically, a source set is a grouping of files that are compiled together and used for building a specific output. So the main one here, if I drop this down, that includes main activity, this is the main source set. And this is what is used to build the APK that we used for the homework. Android Test, this is where we would write any test code that is very specific to the Android framework. Now, we're not going to get too much into testing in this course, probably a little bit later. But for now, I just wanted you to recognize what this is for. And then similarly, the test source set, or the test directory in this case, is for unit tests. And if you're not familiar, unit test is just a small test that basically is independent of the framework. So a unit test wouldn't have to know anything about Android. Android tests are where we would write larger tests like what is on the screen or how are my activities transitioning from one another. So we'll get more into testing and the testing pyramid and stuff later, like I mentioned. But for now, the key thing is to notice that we just have the different source sets. And just to call this out one more time, like I mentioned, we have the main source set, Android Test, and Test. And if we switch this back to our project view, we can see what that looks like. So again, we are in our root level directory here. We expand that. We go to the app module and go to source. And we'll see we have Android Test, main, and test. And then if we were to expand the main, eventually, like I said, we find main activity. So this is just a little bit how Android Studio can give you different options for how to present your files. If you find yourself getting overwhelmed with all the different files available to you when you have the project view open, maybe try switching over to the Android view. If you are getting confused because the Android view kind of moves things around, feel free to use the project view. They're both valid. I use them interchangeably throughout my work as an Android developer, and I think they both serve their purposes. Specifically, I think the Android view is really good when working with resources in particular. Yeah, so one more thing that I wanted to point out too. So, whoops. If we come back over here into Android Studio real quick, I wanted to look at the resources more closely. So if I open up the res directory again here, I'll see different types of resource directories. First, we see drawable. Drawables represent things that can unsurprisingly be drawn to the screen. So this could be an icon. This could be an image. This could potentially be some type of animated GIF or something. Drawables can be used in a number of ways. They could be used in an image view, like we'll see later in the lecture. They also could be used for background of a particular view or view group. Now we've seen the layouts. This is where we define a layout for an activity, and that gets drawn to the screen. Mipmap we saw, this is a special image type, basically reserved only for launcher icons. So we won't really do much with this in this course. I might do a little bonus lecture at some point showing you how to customize your app icon if you want, but not overly exciting there. The last one that is more interesting is the values directory. So if we expand this, we'll see 3 different XML files. If we open up colors XML, this is where we define the colors that we were using in our app theme. And if you click on one of the little color swatches kind of in the left-hand gutter here, you can actually play around and choose a different color. They also have some predefined colors based on material design, and you can come and select one of those and just kind of pick from that palette and use it to customize how your app is going to look. And in fact, this is part of the homework assignment. You'll see it in the week 2 app assignment specification, but I'm going to ask you to come in here and customize the look of your app by changing these colors for your app theme. Now the next file here is strings.xml. Now some of you asked last week about hard coding strings, and I mentioned that typically we don't want to hard code strings for things that are user facing. This is where we would define those types of strings. By defining a string resource, it lets us do a couple of things. It means we can change the resource, or we can change the value of the string based on app configuration. So this could be things like orientation. This could be things like language or locale. Configurations in Android are basically a whole bunch of different things, like whether your app has a keyboard, like I mentioned, the orientation, whether certain functionality is present or whatnot. And we can respond to those and change the look and feel of our app by defining different resources for those configurations. So for strings, the big one is localization and translation. So if we have our app and we wanted to release our app in Spanish, we could define another strings.xml file specifically for the Spanish locale. Then we could define a resource still called app name, but it would contain the translation of our app name for Spanish. Then when our app is run, it can detect what locale it's in and it'll load the proper resource. So this type of configuration is really important. You can use it for dimensions, sizing of things, of text and view elements. You can use it for layouts. You can use it for colors, strings. Really any type of resource file can take advantage of that type of configuration. And we will get into that later. And then finally, we already saw this one again, but styles.xml. This is where you can define your styles and your themes. I mentioned we have a lecture later in the quarter, more specific to kind of styles and themes, but basically you can apply a style or a theme to different views or your application as a whole, and it just changes the look and feel of all of the widgets and how they look by default. So we'll go back over to our notes here. So like I said, we already kind of covered Android versus project view. Both represent your project's files, source code, build files, resources, etc. The project view displays it exactly as it appears on disk. Android view consolidates and reorganizes to match how Android Studio thinks about the project. We saw about our source sets. We had our main source set. This is where we're going to be working most of our time. It's where our main activity is currently defined, and this is what will be bundled by default when we create our APKs. We have the test source set specific for unit testing, and we have our Android test source set specific for Android instrumentation tests. Now you don't need to really worry too much about tests or Android test right now, but I just wanted to point that out so you have an idea of what those directories are doing when you see them in your project. Now we also saw the difference between kind of the Java and the res directories. The Java directory was kind of the root level for all of our Java and Kotlin files. And then the res directory was where we put all of our Android resources like layouts, colors, and dimensions. And then we just saw we have the different directory types. We have drawable resources, layout resource, and then value resource directories. And within that values resource directory, that's where we can define things like strings, colors, dimensions, styles, etc. Strings.xml. Like we saw, we can define any user visible strings here as string resources. We can then reference those strings elsewhere in our code, and that lets us support localization and configuration changes when something about our app changes, whether that be the defined locale for the app, the orientation, etc. Demens.xml. This one, I don't think we actually saw this one in the example. So we can come back over to Android Studio real quick. So if we right click on the values directory here on our left hand of the screen in the project pane, if we right click on that, we can click new values resource file. Then we'll call that dimens, specifically dimens, which is short for dimensions. And then we'll hit OK. So this creates a resources XML element for us, basically. Now within that, we can define dimensions. So we can do that by typing kind of open bracket dimen, name, and then you might define a dimension for something like title text height. And then you might set that to something like 18 SP. So 18 SP roughly translates conceptually to a 18-point font if you're in, let's say, Microsoft Word. The SP is something a little bit specific. It stands for scale independent pixels. We're going to talk more about that later in the lecture. But this is basically how you could define dimension resources in your resource value folder. So we could then use this title text height to define the size of our text. So if we were to go over to our activity main here, if we came to our text view that we used before, we could change this text size property and set it to that new title text height value that we just defined. And so now our text would be 18 SP, which likely is a bit bigger than default. So here probably might be hard to tell on the recording, but this is definitely a bit bigger than it was before. So that's dimens.xml. And then colors and styles we've covered a couple times now, but you can define reusable colors and styles for our views and our application. Now there's a couple other files that I want to point out before we move on from kind of reviewing what was in our project. And that is the build.gradle files. And there's actually two of them. We have one at the root level of our project, and we have another one at the app level of our project. So I want to jump over back to Android Studio once again and point those out. So if you are in the Android view here, you'll see that it actually separates out your Gradle scripts into a separate dropdown. And so we can see the two different scripts are here at the top. We have this one that says project :8340. So this is the root level script that controls configuration for the project as a whole. A Gradle project, which is, let me take a step back. Gradle is a build system, and it's the build system that Android uses to build everything. And what do I mean by build everything? I mean basically take all of the code from all the different directories, all the resources, and it knows how to compile and package them all together and make them into a usable format. In our case, an APK typically. So the project level one lets us configure how all the different sort of modules and directories compile their code together. Now, what is a module? Well, our app folder is a module. It's essentially a grouping of code and functionality. Now, you could have many modules. You might have a module for authentication, a module for your your editing screen and for every different feature, or you can have a single module for everything. The discussion around when and how to modularize is well beyond the scope of this course, so we're going to have a single module for now. But for that one module, in this case our app module, we also have a build.gradle file. This one is much more interesting. So in this one, we are configuring some Android specific things here, like our compile SDK version, the version of our build tools, the application ID, our min and target SDK version. And then down here at the bottom in our apps build.gradle file, this is also where we define new dependencies. And I think it's going to be in week 4, that we'll actually start adding new dependencies to this. But we can see here by our default, our app already has some dependencies pulled in. So we already have a dependency on the Kotlin standard library. We have a dependency on AppCompat and ConstraintLayout. So these are things that just by default Android Studio brings in because they're so essential. Now, like I said, this is the Android view. This is where those files are located if you're using the Android dropdown here. I want to go back over to the project dropdown and just show that as well. So you see, if I have my root level directory here collapsed, you can't see any of them. As soon as I open that up, we'll see the root level directory's build.gradle file is visible. And that's this one here that has less in it. Then if I expand app, I'll see the app level build.gradle file. So the build.gradle file, whether it's in a module or the project as a whole, it's always sort of like one level below that top directory. Okay, now we're going to dive in and we're going to talk a little bit more specifically about activities. And we're going to get into the activity lifecycle, which is a very important concept in Android development. So we're going to look at a couple kind of key questions here. How is an activity defined? We've actually already seen the answer to this as we have been exploring what is created for us in our existing Android project. We're then going to answer the question, how do we specify the UI for an activity? And again, we've really already seen this as well, as we've seen that call to set content view and we pass in a layout resource. And then finally, what is the activity lifecycle? Well, the activity lifecycle looks something like this. And if that looks a little bit intimidating to you, that is perfectly understandable. Quite frankly, it is still very intimidating to me and to other professional Android developers at times. So essentially what this is describing to us is kind of the setup and initialization process of an activity, the teardown and destruction process of an activity, and then there's sort of a secondary loop of how an activity can be restarted in the case where it's maybe put into the background and then brought back into the foreground. So this is roughly the full activity lifecycle. There's actually a little bit more to this even, but it's rarely that relevant to developers. And even what we see right here is more complicated than we need to worry about most of the time. So for us right now, we're going to simplify our lifecycle a little bit more. And we're going to look at these 6 lifecycle methods. And really you can think of these as 3 setup methods and then 3 sort of converse teardown methods. So the lifecycle that we care about starts with onCreate. And now we've seen onCreate in our main activity that we created last week already. So onCreate is essentially signifies that this activity is created, but it's not yet active on the screen. So this is where we set our layout, for example, and we have to set our layout before it's active on the screen. Otherwise, it wouldn't know how to draw anything to the screen. The next method that we care about is onStart. So this means that the activity is visible on the screen, and yet it's not quite ready to receive focus or interaction. So something could be started, but have something else over the top of it, and meaning you can't quite interact with the activity. Now, typically activities aren't going to be in the started state for very long. Usually onStart will be called, and then very quickly onResume is called. And onResume means the activity is visible and it's active in the app foreground. So when you open up YouTube, for example, and you are watching a video, it's in the resumed state. Now, conversely, when an app is put into the background, say because you turn off your phone, or you switch apps, or you pull open the task switcher, any number of things that might cause something else to become active on your screen can trigger some of these other lifecycle methods in more of the reverse process. So when an activity is visible, but something else has taken the foreground priority from it, that means that onPause has been called. And onPause is kind of the reverse here of onResume. Similarly, onStop is the reverse of onStart. So this means that the activity is no longer even on the screen. And then finally, onDestroy is essentially the opposite of onCreate. This means that the activity is about to be destroyed, either because the user navigated away from it and it's no longer needed, or because the operating system needed to reclaim resources. And so we need to handle these states as application developers so that the operating system can sort of instantiate and set up our activities for us, and so they can tear them down when needed. And the operating system can really do this whenever it needs to.
Typically, if your app is in the foreground, it's not going to destroy your app for you because the user is actively using it. But if you put your app into the background by, let's say, opening another app, the operating system might destroy that old activity that is now in the background to free up more resources for the operating system and for the phone. So we need to make sure that we handle the on pause, on stop, on destroy, and then on create, on start, on resume, so that when we bring that app back into the foreground by clicking on it from the task switcher or from the app icon again, it can refresh that old state and bring it back to where we last had it. So before we jump on anymore, I want to open up Android Studio again and go over to main activity one more time and just kind of walk through this in code as well to give you an example or a more sort of visual example of what we're talking about here. So we saw onCreate is kind of the first method that we care about there. Now, if we start typing onStart and we hit enter, we can override onStart. So this would be the next method that we really care about here. Next, if we want to do onResume, once again, we can come here, we can start typing onResume, and it should sort of highlight that method for us and automatically override it if we hit enter. So now after onResume, our activity would be active and receiving user interaction in the foreground. Now kind of the reverse order. We could say override fun on pause. So you see, in this case, I fully typed it out on my own, which is perfectly fine too. Or you can let the IDE sort of autocomplete for you. Notice in this case, there is this little red squiggly line here. Might be a little bit hard to read, but basically it says overriding method should call super.onPause. So notice that in the other overridden methods here, there's always this call to super dot and then whatever the name. So in onCreate, super.onCreate is called. In onStart, super.onStart is called. What that super call is saying is it's calling through to the implementation provided by the parent class. So going back a little bit again, we've talked a couple times about how in this case, main activity here is extending app_compat activity. App_compat activity is an activity provided through Google that takes care of a lot of boilerplate standard code for us. If we really quickly just kind of click over to that implementation, we see here that this is actually quite a large file. Over 600 lines of code go into this. And so we can make use of that code without having to write it ourselves by just calling super and then whatever relevant method. So we need to make sure that we do that so that these lifecycle processes work correctly. So here in onPause, I'll go ahead and type super.onPause. And now I'll finish this off by adding the onStop method and finally onDestroy. So now we have our methods present here, and we can kind of walk through these processes. And just to kind of illustrate this a little bit more, I will do something here. Region, call this setup methods. And then down here, end region, setup methods. And then now we can do region teardown methods. And then one last thing, end region tear down methods. So these are just comments that I've added, and they don't really do anything for us functionally. They're just here to kind of illustrate this. One small Android Studio tip while we're here, if you do write comments in this pattern, so with the 2 forward slashes, a space, and then region, you can actually collapse those regions. And then Android Studio will sort of highlight that as a kind of a contiguous block of code or comments. So it can kind of be nice for organizing code sometimes. So I'm going to expand my my setup methods here. Go ahead and expand the teardown too. Now the next thing I want to do is actually kind of walk through that life cycle and show you actually what is happening as our app is running. And to do that, we want to talk a little bit about the debugger built into Android Studio. So go back over to our slides. The debugger helps you locate and diagnose problems in your application. It allows you to suspend the running of your app at a specific point and then walk through the execution of your code step by step. So when we're running our apps, we have many instructions that are all being run very quickly one after the other. The debugger basically lets us put a pause on that and run those one at a time and let us inspect the output. We can see what the value of a variable is. We can see what the calculation or see what the result of a calculation is so that we can better understand what's happening in our code. Now, to make this work, to get it to stop at those specific points, we use something called a breakpoint. A breakpoint is a line of code at which the debugger will suspend execution of your code. And we will set a breakpoint in different activity lifecycle methods right now to let us stop in each method and kind of see how that process plays out in Android Studio. So once again, we'll go back over to Android Studio. So how can we then set a breakpoint in our application? Well, you can set a breakpoint by coming into the editor view here. So the editor view is where we have our code here, main activity. And kind of in just to the left here, where we have this sort of vertical line, we can click in this space here, sometimes referred to as the gutter. We can click on that space and we can basically create a breakpoint. This little red circle signifies that a breakpoint has been set at this point. So at this point, I now have a breakpoint added to onCreate. I'm going to come down here and click just to the left here in onStart. Again here in onResume. And then I'll do onPause, onStop, and onDestroy as well. So now we have breakpoints attached to our code. The next step is to basically start the debugger so that we can run through this. So there's a couple different ways you can start the debugger. The easiest way is to come up into Android Studio here, and there should be an icon probably to the right of the little green arrow a little bit. And if you hover over this one that looks like a bug, it should say Debug App. Now, similarly, you should be able to go up to the Run menu and also select Debug App. So we'll go ahead and click Debug App. I'm going to start running our code on the emulator or a real device if you have it, whatever device you're wanting to run on. And it will, give me 1 second here to pull up Android Studio or my emulator. There we go. There we go. So you see, it started installing the app to my emulator here on the left-hand side of the screen. And then now over here in Android Studio, it has stopped running the execution. Notice that nothing has happened on the screen. It's just blank. That's because our app has stopped running here in onCreate. And you can see that it's kind of highlighted this line of code over here as well in onCreate. And also take a look at our bottom window here. So we should see this little debug tool window is now open and active. Well, notice in the bottom left hand, we can see a number of method names here. So we have onCreate on the top, perform create, and it kind of goes on and on. This is the stack trace. This essentially shows all of the methods that have been called leading to this point. Now to move on to the next breakpoint, what we can simply do is click this little green arrow here in the left-hand side of this debug tool window. This says resume program. So now I've clicked resume program, and it's go ahead and start running again as normally until it hits the next breakpoint. So in our case, it's now come here and it has now hit our breakpoint and on start. And so if we go back down here again to our stack trace, we'll see, oh yes, on start was called. Over here on the right hand side in this larger window, we see this single line here that says this equals main activity. This is our inspector view. This is where you can check the value of variables and what the current state of your application is. I'm not going to get too far into this at the moment, but basically if you expand that, you can check on the actual state and value. So you can, for example, see the resumed variable on our activity is in the false state, which makes sense because we have not yet resumed running of our activity. So now we'll go ahead and hit resume again. And so now we have stopped in the resume state. And finally, if I hit resume run one more time, we'll see that my activity here is now fully active on the screen. Now, what will go ahead and trigger the reverse process? Well, if I click kind of the home button here to go back to the home screen of my app, we'll see that that has now triggered on pause, which makes sense because the activity is no longer visible on the screen. If I hit resume, it's going to show that on stop has now been called as well because the activity is no longer visible on the screen. And one more time, if I click resume, nothing else happens. Notice that on destroy was not called. So this gets back into what I talked about before. When something goes off the screen, on pause and on stop are called, but the activity isn't necessarily destroyed right away. It's still active in the background. If I, in my emulator, kind of pull up the task switcher here, you see that my activity is still right here. And if I click on this again, it's going to call on start again. And then if I hit resume, it'll call on resume again. So again, notice there, when I brought it back, it didn't start from on create because it hadn't been destroyed. Now, if instead of just putting the app in the background, let's say I actually kill the application. So first I'll need to let this run so that I can interact with the screen again. So I've called on pause, I've called on stop. Now, if I swipe this away, the app should now have been killed. But at that point, it's hard to actually test the on destroy because the app was killed. So it's no longer active. So once again, if we go ahead and click debug app, we'll just kind of walk through that one more time very quickly. So we see on create is called, then on start, then on resume. Then if we go ahead and kind of pause this, see on pause and on stop, and I can go ahead and swipe this away, and now my activity is destroyed and no longer available to us. So that's just sort of the general outline of the setup and teardown process. Now, where this will really become relevant down the line is if you need to sort of initialize certain things, you need to grab references to a view, maybe you need to start loading tasks for some data. You're going to do all that stuff as the activity is starting, and then you'll want to make sure that you clean any of that stuff up when the activity is being destroyed. If you don't, you can run into what are known as memory leaks. Essentially, you can leak the activity and all the memory it needs to run. And memory leaks lead to really poor performance. They chew up system resources that are not really needed. And eventually they can start to slow down your phone until those things eventually get cleaned up by the system. But that can often take quite some time. So you want to avoid memory leaks whenever possible. Okay, so now that we understand how to get a layout onto the screen with our activity, we understand a little bit about the activity lifecycle. Let's start thinking about how we can actually create interactive user interfaces. And to do that, the first thing we need to do is just start exploring what the different types of view elements are that we can put into our layouts. And so there's really three main types of view elements that we can think about. So the first one is a view group. A view group contains other types of views, and a view group can define how those views should be drawn on screen in relation to one another. So you can think of a view group as a container for other views. Now, a view is a self-contained element that can be drawn to the screen. A view could be something like a button, a text view, a progress bar, an edit text. A view can also just be simply a generic view that just knows how to draw, let's say, a colored rectangle to the screen. And then finally, we can actually define our own custom views. So we can extend the view class and define our own behavior that controls how something gets drawn to the screen. And by combining these types of view groups and views, that essentially builds up the user interfaces that we're used to working with in all of our mobile apps. So we're going to start by taking a look at view groups here. And there's really 5 main view groups that we'll talk about, although through the course of this quarter, we'll likely be using only 1 or 2 of them a lot. But so the first one here is a FrameLayout. We'll talk about LinearLayout, RelativeLayout, ConstraintLayout, and then finally CoordinatorLayout. So the first one here that we'll talk a little bit about is FrameLayout. This is probably the most simple of all the view groups. There's no special ordering of views within a frame layout. Basically, anything you put into a frame layout is going to stack on top of one another, and they're just going to be laid out from the top left by default. This is great when you don't need any complicated ordering or laying out of the child views. Maybe you just have one element that you want to fill the whole screen. A frame layout is a great option for how to put that a view on the screen. And so we'll go over to Android Studio here, and I just want to try and demonstrate what some of these view groups actually do for us. So if we go into our main activity here, and then we're going to open up activity main by shift clicking on it, or excuse me, by command clicking on it on a Mac, and I think it's control click on Windows. I've now opened up activity main. Now, if we go into the XML view here, we can see at the top level, we have a constraint layout view group. That's what Android Studio generates by default. And we will talk about that in a few minutes here, but I want to start off by replacing this with a frame layout. Whoops, I clicked the wrong thing there. Frame layout. There we go. And I will need to make sure I update the closing tag as well. Frame layout. All right, excellent. So now if I come back into my design view, I'll see that the text view that was previously centered nicely in the middle based on the constraint layout, it's now placed in the upper left corner here. And that's what I was getting at before. Frame layout doesn't have any special ordering. So if you don't tell it how to lay out within its parent, it's just going to hang out in the upper left corner. And so now if we were to actually add, let's say another text view, and when you add a new element, the first thing you have to make sure you add are the layout width and layout height so that it knows how to draw it. Now I'll just update the text on this, and I'll just say some text here. I'll close this out. Now if we go back over to our design view, we'll see that those text elements are now overlapping each other. So this illustrates the point of a frame layout. It doesn't do anything special unless you explicitly tell it to. So if we come back over into this new text view we added, just for the sake of demonstration, if we wanted to indicate that it should be placed somewhere else on the screen, we could use the layout gravity property. So that's Android:layout_gravity. And we could use center. Now that second text view element is centered in the screen. So frame layouts still support things being moved around from the upper left corner. You just have to explicitly tell the layout where things should go using the layout gravity property. And so this is useful if you have a very small number of elements, but very quickly falls apart if you need complex ordering of elements in relation to one another. So that brings us then to linear layout. In a linear layout, child views are laid out one after the other in either vertical or horizontal orientation. And these are really common and really great for simple UI. So let's jump back over to Android Studio. We're going to go back into our XML view here. And so now we're going to replace FrameLayout with a linear layout. And good, the bottom one has been updated for us. So there's one key thing we need to make sure we do with a linear layout. We need to make sure we specify the orientation so that it knows that we want to lay out the elements either horizontally or vertically. We can do that by starting to type orientation, and we'll see that it suggests the Android orientation property here, and it gives us two options, horizontal or vertical. So in this case, I want to choose vertical. Now, if we come over to our design view here, we'll see that these two text views are now laid out one after the other from the start of the screen. However, there's still a little bit of difference there. We see that our some text here text view is still centered in the middle of the screen, even if vertically it is still right under that. That's because of that property that we added before. So we can start to layer these things. Layout gravity on a child view still can indicate in some sense to the view group how I want it to be laid out. So in this case, this text view is saying I want to be in the center both vertically and horizontally. The linear layout is saying, well, I am going to lay you out vertically based on my own specification, but I will go ahead and honor your request to be centered horizontally. So if we actually remove this layout gravity element here and go back to our design view, we'll see once again, now the text is starting off from the left. So this is again the default behavior, starting things from the upper left. If we come back to that element, we add layout gravity back and maybe this time choose end, and we go back over to our design view. Now this time it's on the far right-hand side of the screen. So this is how we can start to define more interesting behaviors here by combining view group layouts and layout gravity on our child elements. And then just for one last demonstration here, we'll change the linear layout orientation from vertical to horizontal. And we'll see here, now they're being laid out one after another along the same horizontal axis. And that's pretty much it for the moment with linear layout. Like I said, this is a very useful one and is something you'll likely want to take advantage of during this quarter. So now the next one we're going to use here is RelativeLayout. Now RelativeLayout is extremely useful. It's very powerful. There is sort of a newer view group that offers a lot of the same benefits, but with better performance. So we might not use a lot of RelativeLayout in this course, but it is a very popular choice. So I do definitely want to cover it. And basically the point of a relative layout, before I move on, is that child views are laid out relative to either the parent view group or other sibling views. So again, back over to Android Studio, back to our XML here. We're going to start by just kind of clearing out the layout gravity property, all of these constraint properties, and also the linear layout orientation, just because those things aren't going to be relevant here. So now we'll replace linear layout with relative layout. And if we go over here to our design view again, we'll see it looks very similar to the frame layout at the moment. Everything is just starting in the upper left corner. Well, this is because it doesn't know how to lay things out relative to the parent or the other views. And so by default, it just leaves them in that upper left corner. So let's start adding some constraints here. So in our first text view, we could tell this thing to layout align parent, and let's say we wanted to align this to the parent end. So we could use Android : layout align parent end equals true. If we go back over to our design view, we'll now see that that has been shifted over to the right-hand side of the screen. Now let's say we wanted to put them on the bottom right-hand side of the screen. We could say layout align parent bottom equals true. So now that view is going to be aligned to the bottom and to the right-hand side of that parent. Now if we come back and let's go to maybe our second view here, we have some choices if we want to center it. We could choose to center horizontal. We could choose to center in parent or center just vertically. So let's choose center in parent. And once again, we'll mark this as true. We'll jump over to our design view. And now we see that that second text view is centered nicely in the parent. Now, what would happen if we wanted to just always place that second view above the first one? Well, this is where relative layout can get pretty powerful. We can actually make that happen quite easily. We can come down here to our second view and we can start typing layout above. And now with layout above, we can pass in a view identifier and it will lay out above that view anytime it can. So the first thing we have to do then is add layout identifiers to our views. And this is actually a pretty common practice and something we will want to do for our homework and moving forward in the course. So to add a view or add an ID to a view, you come within that view tag within the XML, and you can just start typing ID and you'll end up with Android : ID. And then you need to type @+ID/, and in this case, I'll just call this text view 1. Now this is kind of a weird syntax. @+ID basically says I'm going to create a new ID, and then everything after the slash is the ID of that view. Now down here, I'm going to do the same thing, and I'm going to call this text view 2. Now in layout above, I can reference that ID. So I want to reference the text view 1 ID because I want text view 2 to always be laid out above it. So here I see @ID/text view 1. Now notice in this case, I didn't use the @ sign. I just said @ID and then the name. So when you're referencing an ID and you don't want to create a new one, you don't need to add the plus. So now I've indicated that text view 2 should always be laid out above text view 1, but also centered in parent. So it's going to come down here and kind of reconcile those. So see, text view 2 is now still centered at least horizontally in the parent, but the layout above is taking precedent in laying that view out above text view 1. So you can start to combine these types of constraints and change how those are laid out with one another. So let's say I'm going to get rid of center in parent, and I want to do layout above text view 1, but also maybe layout to left of text view 1. Now if I come over here, I'll see that my view is now to the left of the first one and above it. And so we have kind of this staggered effect. So these are the types of sort of laying out of views in relation to one another that you can accomplish using relative layout. Now, constraint layout is essentially a more modern alternative to relative layout. And it actually it makes a lot more things possible than what relative layout can do. So it's not a direct comparison, but pretty much anything you can accomplish with relative layout, you can accomplish with constraint layout. And constraint layout in many, many cases is more efficient, And the tooling these days is also built to really work with constraint layout by default. So constraint layout is understandably kind of what Android Studio generated for us automatically. And it's what we will be using a lot of in this course. And so in a constraint layout, child views are laid out based on a pretty complex series of equations. The layout design view is built to work best with constraint layout. So that cool little interactive editor we've been using works really well with constraint layout. And constraint layout, its whole thing is about letting us build very flat view hierarchies. And because of that, also can enable complex animation, and all of these things happen much more efficiently. So let's go back to Android Studio, and let's just take an example of constraint layout. So let's just clean this up a little bit. We'll move these layout properties on our two text views. And then we will replace relative layout with constraint layout. So once again, let's look at how this is laid out by default. And again, no surprise, by default, these things are just laid out on the top left-hand side of the screen. Now, in XML, if we wanted to start adding some of these constraint properties, we could just start typing the word constraint, and it should autocomplete some of the different types of constraints we can apply here. Now, it's somewhat confusing when you first get started here because there are so many different types of constraint properties. And so when we're getting started with constraint layout, the actual, the best way to really get started is to actually do it from the visual editor here, which is quite nice. So I'm just going to grab text view 2 here, and I'm just going to drag this down here. Now you see, when I have this selected, I have these 4 little circles. These basically represent, those edges of the bounding rectangle. And so if I want to constrain this so that it's centered in the screen, for example, what I can do is start dragging from one of those circles to different edges of the parent. So you see here, as soon as I grabbed the edge and connected it to the right-hand screen, it snapped to that side. Now, if I come over here and I connect the left-hand side, now it's constrained to both the left and right-hand side, and so it splits the difference and sits in the middle. Similarly, if I connect the top or bottom, now all of a sudden that view is constrained to the center of the parent. Now let's go over to the XML and let's see what that looks like in the XML. So you can see here in the XML, that gets translated into things like layout constrain the bottom to the bottom of the parent, or constrain the end to the end of the parent, constrain the start to the start of the parent, and top to top of the parent. So this is sort of the general syntax in the XML for constraining things. Now let's go back to our design view. Let's say we want to constrain text view 1 here that says hello 8340. We want to make that always be below some text here. So in this case, I'm going to grab the top circle here of text view 1, and I'm going to connect it to the bottom circle of text view 2. And you see now it's brought that down, and vertically it's always going to be below. And now I could connect that to the parent. And so now it's going to be centered horizontally, but always below that first one. And if we go over to the XML again, we can kind of see that. We see we constrained the end to the end of the parent. We did layout constraint start to start of parent. So that was the left and right constraints to the left and right edges. And then we said constrain the top of this view to the bottom of, and then we referenced that view ID. So you can constrain these things to the parent or to specific views using those view IDs. Now, if we go back over here, we can start to do some cool things here. Now, because text view 1 is bound to text view 2, it means that if we move text view 2, text view 1 will move with it automatically. So I've selected text view 2. That's our some text here one. And we pull over our property or our attributes panel on the right-hand side of the screen. And in this layout dropdown, we have some controls here for the constraint layout. And I just want to draw your attention to these two sliders. We have a horizontal slider and a vertical slider. Those basically define what are called the bias, vertical bias or horizontal bias. And the bias is a weighting of sort of, do you want to be centered or do you want to be to more one end or the other? So in this case, I can be constrained to the top and bottom, but have a vertical bias. And you see, as I change the vertical bias on some text here, because Hello 8340 is connected to it, it moves as well. So it lets us to start doing some pretty interesting things. You see here, Hello 8340 is not connected on the horizontal axis. So as I move some text here horizontally, the other one doesn't move. But if I move it vertically, it does. So that's some of the kinds of stuff that constraint layout lets us do. We will talk more in depth about building specific types of layouts with constraint layout, but I just wanted to sort of give you an overview of it and indicate that constraint layout in particular works quite well with this visual editor in the design view, and I recommend starting out with that for sure when playing with constraint layout for the first time. So let's go back over to our notes one more time. Okay, so yeah, that's it. The only other one, I'll back up just a moment. The only other one that we'll talk about a little bit is coordinator layout. Basically, a coordinator layout is a special view group that is mainly used when you have scrolling lists of data. We're going to get into scrolling lists in the next week or two, so it'll come up a little bit more there. But a coordinator basically lets you move certain types of elements on and off the screen in response to scrolls. So it might be something like the app toolbar that hides as you start scrolling and then returns when you scroll in the opposite direction. So coordinator layout is useful, but for like a very specific type of use case. So we won't be using it a ton in this course. Now, we've talked about view groups. Now it's time to talk about some common view types. We've already seen text view in our examples and our homework, but we're also going to talk about button, edit text, and image view. So text view, unsurprisingly, text view displays text on the screen. You can think of it as a simple label. And it can be customized to display complex formatting if needed. So it can be very, very simple, but it can also represent complex things like bold and italics and hyperlinks and things like that. We're not going to go into an example of that because we've been using lots of text view examples already. So we'll move on to the next one. Now the next one is a button. A button is a clickable view that can contain text and supports a click listener for responding to user interaction. So let's go back over to Android Studio and we're going to go into our XML real quick. And we're actually going to change text view 2 from a text view to a button. And then I will update the ID here to just button 1. And then I will need to change my constraint on text view 1 to button 1. Whoops, excuse me, button 1. All right, so now everything should be constrained properly again. So now notice here that instead of a text view, I have this sort of this rectangle that represents the button. And this is actually interactable. If I deploy this to the emulator, which should take a second. So now I have my button here and you can see I can actually click this. If I click down, you see there's a little animation and it changes the color. And as soon as I let off the click, it kind of goes back to normal. So this is our first look at anything really interactive on the Android UI. Now, if we go back to our notes here, next thing we'll look at is an edit text. An edit text is a view for entering and receiving user input.
And it can be customized for specific input types, such as if you need to enter an email address or a phone number. So once again, we will go back over to Android Studio, and now we will change button to be an edit text. We're just going to leave the ID for now. It's a good idea to match the ID with kind of the type of view to some extent. But for our example, we don't need to worry about that now. So now if I go back to the design view, we'll see once again that view looks quite different. And if I redeploy this back to our emulator again, we'll see now we see this thing that says some text here. But as soon as I click into that, I get this little cursor and I can actually change the text that is in there, and I can type into that as well. So this lets me actually enter in own custom data. We'll be using this later on to enter a zip code, which will be the beginning of our weather app. Oops. There we go. And so now the last one we'll take a look at here is the image view. Image views display a type of image or drawable. It can be loaded from an asset, a URL, a resource file. There's a lot of ways we can get an image into an image view. If we go over to Android Studio one more time, we'll go back to our XML. We will change this over to an image view. The text property doesn't really apply here, but what does apply is the source attribute. The source attribute lets us define some type of drawable to set into our image view here. So in this case, I'm going to just pick, I'll pick Icy Launcher because we have that asset. Later on, I'll show you how to kind of create your own drawable or even, import your own. But for now, we'll use our launcher icon and we'll see that we now have this image on the screen. And if we run this, we can see that on our device, I can't click on this. This image view is not interactable by default, although you can add a click listener to it if you want, but we do have that nice image printed out at the screen. So those 4 view types, text view, button, edit text, and image view, those are going to be our primary focus for this week. As we move on, we'll add some more complex view types, but those are really some of the core building blocks of any Android application. Okay, so now that we have an idea of the different types of views and view groups that we're working with, we're going to actually start working towards our first real interactive user interface. This is going to be essentially what the week 2 app assignment is about. So we're going to walk through how to get a reference to a view, how to add a click listener to it, how to get user input, and then display some type of interactive message to the screen. So we'll go back over to Android Studio here. Once again, we're starting off in our main activity, and we're going to go back into activity main here. And now what we ultimately are going to want is a image, an edit text, a button, and I think that will be it. So we're going to walk through how to add some of those elements here and how you can get references to them. So to start, we're gonna leave our text view here, but we're gonna call this text view something like title. And then we're going to change the text of this text view to be something like enter your zip code. And that should be good for the moment there. Then we're going to come down here and we have our button. We're going to change the ID on this button to be something like enter button. And then we will change the referencing ID as well.
So enter button. Now, we don't want this to be the simple app icon. We want to do something more interesting here. So what we can do is come over here to the left-hand side of the screen to our project window. Here I'm in the Android drop-down version, but it works the same if you're in the project version here. But basically, I'm going to go to the drawable directory here, right-click, go New, and I'm going to scroll down here to Vector Asset. I'm going to click on Vector Asset, and it brings up this thing called the Asset Studio. This lets us import an image from a local file or use some of the default clip art. Now, if I want to change this, I can click on the clip art icon and it'll bring up this whole set of material design icons that I can use. So in our case, we want to use something that indicates location. So I'm just going to type location and see what comes up. And in this case, we have a number of icons that all seem to indicate location. I think in my case, I just want to select this location on icon that just shows like this little point on a map type of icon, but there's no real right or wrong here. And I'll go ahead and hit OK. And here you could customize the color if you wanted. By default, leaving it black is fine because you can usually change the color in other means down the line. You could also update the name if you wanted, but again, I think the default one here is fine. I'll hit next and then I'll hit finish and I'll hit add. So now if I go to the drawable directory, I see that it has added this XML, and this XML is a vector drawable essentially. We're not going to get too much into that right now. I don't want that to distract us, but basically what that means is that we can now come here to our source property on our image view and start typing IC location on black. And now we see that we have this little location icon there. So now we have a little icon. We have our title image. We need to update the ID of our image view here. Sorry about that. We're just going to call that icon. Now we're going to go ahead and enter our edit text. So again, we'll do an edit text here. We're going to say wrap content for the height and width. For the height and width, wrap content essentially means I'm going to only be as big as I need to be to contain whatever sort of text or other properties are added to me. So by default, you generally want to go with wrap content. So now for our edit text, what we can do here is supply a hint property. This hint is basically a piece of text that will disappear as soon as the user puts their cursor in there, but it indicates what they want to do with that edit text. So here we're going to say enter zip code. And if I go back to the design view, we now see our edit text right there. I'm not going to worry about constraining this at the moment. I'm going to do that at the end. And we're going to give an ID here of ID, zip code, edit text. And then one last thing, we're going to change the input type property. So we're going to do input type. And you see here we have a number of different types of input that are available to us. In our case, zip codes are number. So I'm just going to select the number version there. And that should give you some nice things like when you press into that, your keyboard will pop up with only numbers instead of letters and numbers. Now, our last element here that we're going to need is the button. And again, we'll do wrap content for height and width. And for text, we are going to go ahead and just say submit zip code. We're going to hit enter. And we'll see that we have our submit zip code element there. So now we want to actually constrain this in some way.
So in our design view here, we can play around. For the homework assignment, there's not going to be any real requirement around what exactly it looks like as long as all the elements are on the screen here. So what I want to do is I want to constrain the icon to the left-hand side of the zip code. And I'm going to constrain its height to the zip code as well. Or I'm going to try and do that here. Come on. Actually, it'd probably just be faster to go here. I'm going to remove any of the previous constraints just to make this a little bit simpler on ourselves for the demo. All right, there we go. So everything should be good now. Now we can go in and actually edit this stuff on our own. So I'm going to grab the button and just pull the button down here, kind of get it out of the way. Same thing with the edit text. Want the edit text to always be above the button. So I'm going to constrain the button to the bottom of the edit text, and I'm going to constrain its left and right to the edit text as well. So now the button will be centered based on the edit text. And now I want the title and the icon to also be kind of centered in alignment with that edit text, but also with each other. Just bear with me here as I'm trying to update this. I'm just gonna go down here to my image view and delete these again. I think for the interest of keeping this more straightforward, like I said, it doesn't really matter so much what exactly this is going to look like for your homework assignment. So I'll just stack these. I will stack them on top of each other and have it look something like this. And so now this should be roughly centered in the middle of the screen. I'm going to attach the edit text to the parent so I can adjust its sort of vertical weight. And so now I have something like this, where all of these things are constrained together so they move as a group. And now we should be able to enter a zip code, click the button, and actually do something interesting with that. So to do that, we're going to come over here to main activity. And if we want to get a reference to any of these views to actually work with them, the first thing we need to do is come into onCreate, and we need to create a new variable that references that view. Now, how do we do that? Well, let's start off by getting a reference to the edit text. So we're going to create a variable. To create a variable in Kotlin, we can use var, or we can use val. The difference being a val cannot change down the road and a var can. So in our case, we're going to do a val, and we're going to call this zip code edit text. And we're going to define it as a type of edit text equals, and then we can do find view by ID. Find view by ID lets us pass in a view ID, and it will look for that ID within the current inflated layout of the activity and pass a reference to that view. So in our case, our view is called r.id.zipcode edit text. So now we have a reference to this zip code edit text, and we could manipulate properties on that as needed, which we will look at in just a moment. But first, let's get a reference to our button. So in this case, we'll say val enter button colon button. So once again, this now lets us specify a variable called enter button, and it has the type of button. Notice the types here of edit text and button match exactly the types that we were using in the layout XML. So now again, we'll hit equals
find view by ID, r.id dot, did I forget to add a ID to the button? Yes, I did. So this is actually a nice example. You can't reference a view by ID if it does not have an ID. So here, I'll call this enter button. Come back here. So now I can reference enter button. So now we have references to both of these. We have them as variables, and we want to do something interesting with these buttons. So what we can do is add a click listener to our enter button. So to do that, we can start typing enter button to reference our variable of type button. We then want to call the setOnClickListener method. So to do that, we hit dot. The dot access syntax lets us invoke a method on a object, and then we call setOnClickListener. And you have two options here. They're both effectively the same. The easier syntax is to use this syntax here that has an open and curly brace. In the Kotlin world, this is known as a lambda. Within this lambda, we can now define what happens when our button is clicked. So to start, we're just going to add some very simple feedback. We're going to use something called a toast, which is a funny name, but bear with me. So to add a toast, we'll just start typing toast dot make text. Make text here is essentially a factory method that is going to help us return this toast object, which will display a simple message to the screen. Make text requires 3 arguments. The first one being a context. Now we haven't really talked about context yet, but essentially a context is a special type of object in Kotlin that knows the certain current configuration of our app. So things like the locale, the orientation, what resources should be loaded. Now, thankfully, an activity is a valid context. To reference our current activity, we can simply type this. This refers to the enclosing class of main activity. Then I'll hit a comma, and now it's going to ask us for some text or a string resource identifier. So for now, I'm just going to pass in a string that says button clicked. I'll hit comma again. And now for duration, there are a couple predefined durations we can use, and we can reference them by typing toast.length short or long. So in this case, I'll do toast.length short. And now after this, and this is very important, we have to go outside of the furthest parenthesis and type dot show. So now this is going to create a toast that will say button clicked, and it will show it. And that should happen anytime our enter button is clicked. So let's test this out real quick by deploying our app to our test device. So we can see here we have our elements on the screen, although notice they're not in quite the same spot we looked at before. We'll come back to that in just a moment. But now, if we click our button there, we see that button clicked was printed out to the bottom of the screen. So that's what a toast does. It's a simple transient message that's a nice way of giving very quick feedback to your users. And we're going to play with that some more in this demo. But first, let's go fix the layout. So if we come back to Android Studio and we come back over here to Activity Main, we'll see here that it looks like it's centered. However, on our emulator, it wasn't centered. It was stuck to the left. So that indicates that there's some type of issue here. Well, if we come back into the XML, if we scroll through this and we look at our edit text, we'll see this little error saying this view is not constrained horizontally. At runtime, it will jump to the left unless you add a horizontal constraint. So that's exactly what we're seeing here. So this is one small thing to be aware of when using this design view, is that there can be certain differences. Thankfully, the key issue here is that everything we have is basically being laid out based on the position of our edit text. Now, our edit text
we constrained vertically, but we didn't tell it how to be constrained horizontally, and which is why it's jumping to the left. So to fix it, we simply need to constrain it horizontally to the parent. Now, if we run this one more time and look at our emulator, now we see that it's fixed. It's in the middle, and one more time just for fun, we will click our button. All right. Come back over to Android Studio, go back to main activity. So now we want to do something a little bit more interesting. What if instead of clicking or just displaying the same button clicked message every time, what if we displayed whatever the user had entered into the zip code edit text? So to get the value of whatever is entered in the edit text, we can use a simple property lookup. So within our click listener here, because we want this to happen every time it's clicked, we're going to type val zip code, and it's going to be of type string equals. Now we're going to reference our zip code element directly, dot text, dot to string. So what we've done here is we've said, go ahead and grab whatever text has been entered into the edit text. So that's this text property. We're going to convert it into a string, and then we're going to save that into this zip code parameter right here. So now, once again, we're going to create a new toast.makeText. This time, instead of passing a string in, we're going to pass in our zip code variable, comma, toast.length short, and then we'll show it. So let's go ahead and rerun this. And if I click submit, we see that a toast was created, but it was empty, which is actually to be expected because we haven't entered anything in zip code. The phrase here, enter zip code, is the hint and doesn't get returned when you use the text property. So if I enter a zip code here, 98119, and I click submit zip code, now we see the toast displayed at the bottom of the screen. And if I change this, 981, we see 981. So that is actually quite helpful for us here. Now, let's do a little bit of user input validation. This will become really important as we start building out our weather app because we're going to want to enforce that our zip code is valid. So we're going to start getting into some conditional logic here. Essentially what we want to do is check the length of the zip code value once we have it, and then display different input to the user based on whether or not it's valid. So to start, we're going to use an if statement. So we'll type if, and then we're going to reference zip code dot length. So that gives us the length of the value stored by the zip code variable. If zip code dot length less than 5, or actually we'll go ahead and rethinking how I want to do the logic here. So let's just say if zip code dot length does not equal 5, in this case we would want to make this some type of error message. Else, and in the else clause here, this is the successful case. So what we can do is just copy and paste our toast to start. So in the successful case, we'll go ahead and print out the zip code just the same as we did last time. In the error case, instead of passing the zip code, we'll put in a string that says, please enter valid zip code. And now we will run this one more time. So now if we click the button, we see please enter a valid zip code. And if I enter, let's say just 3 numbers, once again, please enter a valid zip code. If I add 2 more numbers, now it's printing out the zip code for us. And so that's exactly what we want there. That has allowed us to provide that conditional validation and give some feedback to our users around what they should expect here. So now let's fix a couple of other small things here. We talked about how we should use strings.xml when presenting user-facing strings. So let's make a user-facing string out of this. Please enter a valid zip code. So we'll come over here to values. We'll open up strings.xml. And we'll call this string zip code entry error. Please enter a valid zip code. So that's a good error message for now. If we come back to our main activity, now instead of passing a string directly, we can pass the string resource. All right, so that is one just small update we can make to that. Now, if we go back to main activity here, we notice that everything is roughly the same size. So let's tweak this a little bit by taking advantage of some dimensions. So if we come over to dimens.xml, we have this title text height. Let's change this to something quite a bit bigger, maybe something like 24 SP. We'll go back to activity main, and we'll see now enter zip code is quite a bit larger. If we run this, we see that that's looking a little bit better there. It's spaced out a little bit more nicely on the screen. Now, I want to make the size of the image a little bit bigger here. So if we go into our XML for our activity main layout, we see that the size of this image view is set to just wrap content. And by default, icons are 24 dp. So 24 is pretty small. So I want to maybe change this to something like 40 dp. And like I mentioned before, I believe, remember 40 dp, similar to SP, 40 dp means I want this to be 40 roughly pixels tall, regardless of screen resolution. So DP stands for density independent pixels, and it's just a way of ensuring things are the same height everywhere. So anytime you're specifying a height or width of an element, you should use DP. Anytime you're using size of text, it's SP. So here I've updated the size of my image to 40 dp, and we see now it looks bigger on the preview. And if I run it in the app, we'll see it looks bigger there too. So that's a nice improvement. However, again, this is hard coded here, and it's typically good practice to use dimension resources for this type of thing as well. A good reason is that we might want that icon to be even larger if it's on a large tablet instead of a smaller phone. So we'll come over here to dimensions, and we'll create a new dimension resource, and we'll call this zip code entry icon, and maybe add something like size there. And then we will define 40 dp. If we come back over here, we can now reference that dimension resource by typing @dimen zip code entry icon size. And we want to do it for both height and width. So we'll do it one more time. And now if we preview this one more time, we see that everything looks the same. So that is excellent. Now there's one other thing here I want to just make sure we call out, is that the style of my app is not the greatest right now. I have kind of a weird color palette. This pink, purple, yellow is not the best color palette out there. And so I can see that in my app theme, I'm setting color primary, accent, and primary dark from these color resources here. So I'm going to go over to the colors.xml file, and I'm going to edit these to create a theme that looks a little bit nicer for my liking. So for my color primary, I'm going to come in here to the material 500 range, And I'm going to choose something, probably this yellow. That's fairly close to sort of my personal kind of brand colors I use. So I'm going to go with that. For the color primary dark, I'm going to click here again. And this time, instead of material 500, I'm going to do material 700 and choose kind of that same yellow, but just the 700 variant of it. And now for an accent color, I'm going to choose something, I don't know, let's play around here. Maybe I'll just go back to material 500, but for my accent, I'm going to maybe use this sort of this greenish bluish color here. So if I rerun this now, hopefully my app looks a little bit better. There, to me, that at least looks a little bit more consistent. So I'm happy with that. So that should be about all we need for to get started with these user interactive elements. And just some extra review here, like I said, text sizes should use SP, view sizes should use DP, and colors can be defined in colors XML and then applied to views and styles appropriately. SP stands for scale independent pixels. Defining text size uses SP to enable the operating system to update the text size of elements based on the scale settings of a device. This is done to support users with poor vision. DP stands for density independent pixels. This means that a value defined using DP will be the same size whether on a low pixel density screen or a very high resolution screen. And we should use DP when defining sizes for view groups or views. Colors can be defined as reusable XML elements and can be used things for like background colors on views, for text color, really anywhere we want a color resource. All right, the last thing I want to cover in this week's lecture is just very quickly how to start testing on a real device. And so testing on a real device is very helpful if you don't have an emulator, or if your computer's a little slow and the emulator doesn't work well, or if you just want that more tactile feedback of what it really feels like using your hands and fingers and input. So if we go to our desktop here, the first thing we need to do to start testing on a real device is enable developer options. Enabling developer options is a little bit different depending on the version of Android that you're using. I've created a previous video on how to do this, and I'll link that in the lecture notes. So if this demo isn't quite what is working on your device, maybe that one will work a little bit better. Ultimately, it all comes down to kind of the same stuff though. So what you need to do is go into your phone's settings. Now, what you want to look for is ultimately kind of in the system settings, possibly under the advanced section. Eventually, we're going to see something called developer options. However, here we don't see that. To enable developer options, there's a bit of an Easter egg in the operating system. So you can go to About Device. I'm doing this on an emulator. It's the same process for a real device though. So you go to About Your Device, and you're going to come down to where it says Build Number. And then you're going to tap that 5 times. 1, 2, 3, 4, 5. Actually, I guess it's more times. But eventually, you'll see this thing that says, "Yay, you are now a developer. Congratulations." Once you've seen the "You are now a developer" thing, come back to System. In this case, I need to expand Advanced. And now I see Developer Options. If I click Developer Options, we now have a whole bunch of options in here that make developing Android apps easier. The one that we're concerned with is USB debugging. So scroll until you find USB debugging, or you can use this little search and just type USB and hit enter. And it'll also find USB debugging, in which case you can just click on that and it'll take you right to the option. You're going to want to make sure USB debugging is turned on. So on the emulator, by default, it's turned on. But when you turn it on, you should see something like this: allow USB debugging, and then blah, 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 blah. You'll hit OK. At this point, you should be able to plug in your real device, connect it with a USB cable, it'll likely prompt you to ask, do you want to use this device for development? That should be a one-time thing if you say like, don't ask again. Once you've clicked OK on that, Android Studio should recognize your device and you should be able to now deploy your device just like you would an emulator. So if you go into Android Studio here, and let's try and connect this. I will try and connect my own device here to Android Studio. So as soon as I've connected this, I see a message that says allow USB debugging. And I will go ahead and check the box that says always allow from this computer and click allow. And now in Android Studio, if I go to the device dropdown, I see Google Pixel 2 XL, which is my personal device. And so now I can go ahead and run that directly to my phone. So that is the process for setting up your personal device to test with Android. Like I said, I'll link to my other tutorial that goes a bit more in detail on that, but I just wanted to point that out because a couple people had asked about it. All right. Yeah, just a little bit more about developer options here. We probably won't get too much into it, but there are a couple specific options that I will point out, and I will link to some extra resources for this too, just in case you are curious. And that is it for the week 2 lecture. So as of course, there'll be some more review and stuff in our live class, but this should be pretty much everything you need to help get you through the homework and to continue to build that foundation as we think about building our weather app going forward.